Okay, so here's the last example we were talking about in class using the difference quotient. Sorry, making sure my airliner is working. Okay, using the difference quotient, you would do this first part, so f of x plus h, and that would be x plus h squared. Anywhere we see an x, we replace it, minus 4 times x plus h plus 7. So I literally, this first part goes with this, f of x plus h, and then minus f of x, always put it in parentheses so that you'll distribute, okay? And then we simplify, so x squared cancels because it's plus and minus x squared, 7, negative 7, 4x, negative 4x, and this is what we get. Then you factor out the h, and you're left with 2x plus h minus 4, but then as h approaches 0, 2x plus 0 minus 4 is just 2x minus 4. Alright, this next one, if the height h of a right circular cylinder is twice the radius r, express the volume v as a function of r. This was just to get you working with volume. You know, the other day it was 4/3 pi r cubed. That was a sphere. This is a right circular cylinder. So if you think about that, the base is a circle. Okay, I know that doesn't look like a circle, but, and then it goes up, and the top is a circle. That same circle, right? So I want you to think about volume and what that is. Volume is three-dimensional, right? Well, if this is a circle, we know the area of that circle is pi r squared, right? So you're literally taking this circle, and it's being repeated and repeated and repeated and repeated all the way up to here, which is h, right? So usually the volume is then pi r squared h, because you literally take all these area, the area of the circle, and you multiply it by h, because that's how many times that circle occurs, okay? So if the height h of a right circular cylinder is twice the radius r, h is equal to twice the radius, express the volume v as a function of r. Well, if v is equal to pi r squared h, then v of r is going to equal, I left out the h, if y'all were here you'd tell me, pi r squared h, here we go. Then it's going to be pi times r squared times, and what is h? 2r, so we just replace it and then simplify, so it's 2 pi r cubed, because 2 comes to the front, and then r squared times r is r cubed, and now it's volume as a function of r. Isn't that cool? Alright, examine the symmetry. We already talked about that some today when we were drawing those graphs. So this is what I want to get to, even and odd functions. A function is even if f of negative x equals f of x. The graph of an even function has y-axis symmetry. So you need to know that. Okay, so f of negative x equals f of x. And I'm going to show you with these examples what I mean by that. But literally, it just means plug negative x into the function. And if you get the exact same thing, and, oops, I left out the words, and if you simplify and get the exact function, the exact same function back, then it's even. Which means if it's even, it has y-axis symmetry. So what's cool is if you determine a function's even without even drawing the graph, you then know it has y-axis symmetry. Okay, so let me show you up here. I'll write it to the side. You have way more room on your papers. For example, if I do f of negative x when f of x equals x squared. So that means I literally plug in negative x, okay? So then f of negative x would equal the quantity negative x squared. But what is negative x squared? It's x squared. Well, do you see that f of x is the same as f of negative x? They're x squared, x squared. So what does that tell me? It tells me that the function x squared is even. So then for this one, a function is odd if f of negative x equals negative f of x. that means your original function, all the signs get changed. Basically, that's what that means. Negative f of x. It just changes all the signs, okay? And a function is odd if the graph has origin symmetry. It's very simple to remember this one, okay? O goes with O. Odd has origin, okay? And even has y-axis. And the way I always think of even functions is x squared. That's the one I always think of. And clearly x squared, if I were to draw that, x squared looks like the u, right? That clearly has y-axis symmetry. Now you're probably going, but what about y-axis origin? What about x-axis symmetry? No, we don't talk about x-axis symmetry because it wouldn't be a function. And these even and odd, they have to be functions. So that's why it's y-axis or origin, okay? So now let's do these examples. Determine if the function is even, odd, or neither. So all you do is plug in negative x. So what is f of negative x? It's quantity negative x cubed minus negative x. And then you simplify. Negative x cubed is literally negative x cubed. But you drop the parentheses because negative x times negative x is positive x squared times negative x is negative x cubed. Negative negative is positive. So is this function identical to this function? No. So it can't be even. So what I suggest is factor out a negative, and see if you have negative f of x. Meaning, do you have negative and then the original function back? And do we? Do we have negative f of x? Yes, we do. So since f of negative x is equal to negative f of x, do you see that? Let me show you with the highlighter since you're not in here. This is f of x, right? So when I got to this step, it wasn't the same as this. So I'm like, okay, well, it can't be even. So then what I did was factored out a negative right here, and then look to see if what's in parentheses matches the original. Since it does, it's negative f of x, so it is odd. Okay, so let's do this one. We're going to substitute in negative x. We get negative x squared plus 1. Negative x times negative x is positive x squared plus 1. And if I look, they're the exact same. So f of x equals f of negative x, right? They're equal, they're the same. So it means it's even. All right, one more. Let's do this last one. F of negative x is negative x cubed minus quantity negative x, all divided by quantity negative x cubed minus 4 times negative x, which gives me negative x cubed plus x all over negative x cubed plus 4x. Alright, a word of caution. If it is a fraction problem like this, always look to see if you can simplify, first of all, right? So up here I could factor out an x, I could factor out an x and simplify. And actually, since the leading coefficient is now negative, I'm going to factor out a negative x, and I'm left with x squared minus 1. If I factor out a negative x down here, I'm left with x squared minus 4. Right? You see that? And those would cancel, and so I'm left with x squared minus 1 over x squared minus 4. So you're probably going, okay, but now is it even or odd or neither? You know, if you get that neither one of these are true, then the answer is just neither, okay? But let's look. So I factored out a negative x and canceled it out, right? So now I'm not really sure. So up here, I'm going to factor out an x. So I get x squared minus 1 over, I'm going to factor out an x in the denominator. So x squared minus 4. Those x's cancel because that's a 1, and I'm left with x squared minus 1 over x squared minus 4. So always look for GCFs. you know, when you have a fraction, a problem involving a fraction, it's a little different. So always look to see if you can simplify the original problem. And I got x squared minus 1 over x squared minus 4. Let's look at what I got when I factor out a negative x. I get x squared minus 1 over x squared minus 4. So f of x is equal to f of negative x. So surprisingly, this one is also even. Always look to see if you can simplify by factoring out a GCF. Okay? So what's this little fish over here telling us? If given the graph, use symmetry to decide. So if you're given a graph and it has y-axis symmetry, then the function is even. If the graph has origin symmetry, the function is odd. And if a graph has x-axis symmetry, it's not a function, so we don't talk about it because it's not a function, right? It doesn't pass the vertical line test. All right, one more slide. I know there were several more application problems, but it was just using the difference quotient, and we've already done several of those, okay? So that's why I'm going to stop with this one. All right, find the distance. We've done that before. Find the distance between the points of intersection of the graphs. So we have y equals x squared plus 1 and y equals 2. Now, a lot of people always just want to graph it, and then they're like, ooh, there they're intersecting. But if it doesn't work out perfectly, you know, on a point like 1, 2, what if it's 1 1/2, 2 3/4? Well, you're not going to know. So the way that you find it algebraically, I want you to find them algebraically, is to set them equal, because y equals this, y equals this. If they're both equal to y, then they have to equal each other. So x squared plus 1 equals 2. And now you just solve. So this is a quadratic, so I want it set equal to 0, right? Or do I? No, I don't have to. Look, there's no x term, so I can just subtract 1. X squared equals 1. Square root, x equals plus or minus the square root of 1. So x is equal to plus or minus 1. Okay, so how did that help me? When x is negative 1, y is 2. You know how I can verify that? I can plug it in right here. Negative 1 squared plus 1 is 1 plus 1, which is 2. So here's one of my points of intersection. Your answers are always points, okay? The other one is 1, 2. So now it says find the distance. So there's my points of intersection. If you graphed these two, this quadratic and this horizontal line, you would see at these 2 points it's intersecting, okay? But I don't want you to find points of intersection by just graphing it. I want you to algebraically do it by setting them equal and then solving for x, okay? Then once you find x, plug it back in. In this case, it was really easy because this is a constant. But plug x back in, and it'll give you your y value for each of them, okay? You have a problem like that on your homework, so that's what I'm telling you. All right, so now we're going to find the distance. So d equals, do your distance, dudes. Subtract the x's, so negative 1 minus 1. Subtract the y's, 2 minus 2. Then you square them. Then you add them. And last step, you square root. Okay, so we get negative 1 minus 1 is negative 2 squared plus 0 squared, square root. Negative 2 squared is 4, so we get the square root of 4, which is 2. So the distance between the points of intersection is 2. If I were to graph this, x squared plus 1, y equals 2, I'm just trying to get you to see how everything goes together. So I do want you to look at the graph now last. Notice I didn't solve this by graphing it. And you know me, it's going to be a terrible picture. So I'm going to graph y equals 2. Because I can't draw a straight line. Y equals 2. And then I'm going to graph this one. It's x squared, which is the parent function, plus 1. That means it shifts up 1. So 0 squared is 0 plus 1 is 1. And then 1 squared is 1, plus 1 is 2. So you see how it's literally shifting up my parent function? Everything's shifting up 1. And then 2 squared is 4, plus 1 would be 5. So 2, 3, 4, 5. And it would be that for negative 2 because it's symmetric. So do you agree that they're intersecting? Ooh, terrible. I told you with the airliner I can't draw graphs. Do you agree that they intersect at 1, 2 and negative 1, 2? Yeah, I can see that. I found it algebraically, which is what you need to do. So what's the distance between these two? 2. And that's it. I will go over a few more of these examples, but I'll probably do it on test review day. Okay? So now you can complete the homework, which was the worksheet. Make sure you do those 2 problems in the book, and then problems 1 through 20. Thanks so much.